Welcome back. Now, our drone turns to face us, but it's always facing exactly where we are, and that's because we're setting its rotation every frame. And this could be a little bit smoother. I'd like our drone to turn and face us smoothly. Now, it's not that noticeable because we start the game with the drone just facing us like this, but if we were to make the drone delay for a couple of seconds before turning to face us, we'll see that it's going to just snap its rotation to face us. So I'm going to show you an easy way to delay something with a delay node. In our event graph, we can right click and search for delay and get a delay node, which is going to do what it sounds like. It's going to delay the flow of execution of our execution wire. So this get all actors of class and everything that follows after is not going to happen until this delay has completed. So if we go ahead and hook this up and change the duration of our delay to, let's say, 2 seconds, then on begin play, the flow of execution is going to pause right here at the delay for 2 seconds before it continues on. Now, the implications of this are very important, and it's important to understand something before we move on. These nodes will not be executed for 2 seconds, which means this target pawn variable will not be set for 2 seconds, which means that our tick function is going to try to use a variable that has not been set yet. This is an empty variable. We say that it's uninitialized. And that means it's not going to have a valid value. Let's see what happens if we just try to do that. I'm going to press play, and I'm going to press stop or close my window. And take a look at this. Our message log is filled with errors. And the errors say accessed none, trying to read property, target pawn. And we know that for 2 seconds, that target pawn was empty. Its value was none. That means it hasn't been set yet. So we're trying to call set actor rotation on target pawn when there is no target pawn, not for 2 whole seconds. So how do we prevent ourselves from trying to access a variable whose value is none? Well, there's a couple ways. First, we can check to see if target pawn has a valid value first before we try to use it. There's a couple ways to do that. The first is to get our target pawn, drag off of it, and type is valid. Now there's a couple of utilities. We have a function called isValid, and we have this other type of node with a question mark. Now if we choose the one with the question mark, we have something that kind of looks like a branch. It has 1 input execution pin and 2 outputs. It actually is a type of branch. What it does is it takes the input object, checks to see if its value is valid, and if so, the isValid execution wire will be executed. And if not, the isNotValid execution wire will be executed. Using this, we can prevent the execution of anything hooked up to isValid if target pawn is not valid. Let's hook this up. Event tick goes to exec, and isValid goes to set actor rotation. If we go ahead and press play, we can start our game, we can exit, and we have no errors in the message log, which I'm going to close now. So that's one way to prevent ourselves from executing any code if a given variable is not valid. And there's another way, and that is to get our variable, target pawn, right-click on its node, and all the way down at the bottom, we see convert to validated get. If we click on that, we now have a single node that does the same thing as these 2 nodes. It checks to see if target pawn is valid, and if so, executes the isValid execution. And if not, executes the isNotValid execution, which we could put some kind of a print string there if we wanted to, warning us that we're trying to access something that's not valid, etc. So the validated get is a nice compact form of using the isValid node. I personally like to use the validated get more, but you can use either one. They're both perfectly valid options. So we can hook this validated get up to event tick and only execute set actor rotation if the target pawn is valid. Okay, so now that we know how to prevent ourselves from getting errors from accessing invalid object references, let's now turn back to what we wanted to see, which was what happens if we delay for 2 seconds before setting our actor rotation. Let's press play and wait for 2 seconds. And there we saw it. Our drone just snaps to face us, and it's really jarring. Let's see it from the side. Boom, see, it just snaps, which kind of looks cool, but also it would be better if it were a little bit more smooth. And that's where interpolation comes in. So we're going to learn a new node designed to interpolate rotators. Let's right-click and type rinterp2 and select rinterp2. And if we hover over it, the tooltip tells us, tries to reach target rotation based on current rotation, giving a nice smooth feeling when rotating to target rotation. So we're going to have a current rotation that we hook up and a target rotation. And this node gives us the result that is somewhere between current and target according to a speed that we set. And notice rinterp2 is designed to be used with tick. It has a delta time, and that is the delta seconds that we have in our tick event. So I'm going to make a little bit of room so that I can move rinterp2 right here. And I'm going to hook up delta seconds into delta time because rinterp2 expects a delta time. Remember frame rate independence, right? In order to change something in the tick function, taking delta time into account is the way to make sure that we get consistent behavior across frame rate variations. So let's see how rinterp2 works. We know that we need a current rotation, and that's going to be our drone's rotation this frame. We can get it with get actor rotation. We'll hook that in for current. But we also need a target, and that's going to be the target rotation, which is the rotation calculated with find lookat rotation. So I'm going to bring that over here. I'm going to break that pin, holding Alt and clicking on it, and I'm going to hook this rotator in for the target. So rinterp2 is going to give us the rotation this frame necessary for a smooth rotation. It's not going to be exactly at the target, but it will be a value that's going to approach the target smoothly from frame to frame. So we can hook that into set actor rotation, but notice there's one other input for rinterp2, and that's interp speed. The value we use here determines how quickly our return value is going to approach that target rotation. So let's first try with a small value. I'm going to put in 2. And let's go ahead and press play and wait for 2 seconds. And there we have it. Our drone is slowly rotating to face us. And as we change our location, our drone is going to slowly turn to face us because we're using an interp speed of 2, which is relatively slow. Now, we can change that, though. Let's bring that on up to, let's say, 8 and see how quickly that rotation looks. There we go. It's a little bit faster, right? It's still smooth, though. And the higher the value, the faster rinterp2 is going to work. It's going to give us a rotation between current and target, and how closely that rotator is to the target, well, that's determined by rinterp speed. And it can be quite creepy to see a drone slowly turn to face us. It looks ominous, it looks dangerous, and I like that effect. Another nice quality of this is that if our drone is constantly shooting at us with, say, some kind of projectile, and we're moving around, we can dodge that projectile. If we're constantly moving, those projectiles are going to trail behind us rather than just being shot directly at us, which can be very difficult. That can be intense skill-wise for a game. Now, we'll get to projectiles soon. For now, we've got a very important milestone under our belt, and that's how to interpolate values. And we can interpolate other types of data as well. It doesn't have to be a rotator. There is also a vinterp2, which takes in 2 vectors and returns a vector between these 2. And it works in very much the same way. There's also an finterp2, which takes in floats and returns a float. So interpolation is not restricted to the rotator type, but the concept is the same. We use this typically in the tick function to smoothly transition from one value to a target value according to an interpolation speed. So now that you know how interpolation works, we're ready to move on. Excellent job, and I'll see you soon.